Hello and welcome. I am your host and speaker, Satya Pradhaturi, and I am a technical lead at Infometry. Thank you for taking time to join us today. In today's webinar, I would be talking about key concepts of data modeling. Please feel free to drop questions on the topic or share your struggles and experiences during this live session. We will answer your queries through chat. So without any further ado, let's start the session. The session has been organized by Infometry. We are a pure play data analytics company based out of Fremont, California, with our offshore development center in Bangalore, India. We came into inception back in 2010, and since then, we have been offering domain-specific analytic solutions for high-tech, energy, life sciences, retail, manufacturing, and also finance customers. Infometry has been an engineering and consulting services partner for companies like Informatica, Matillion, Snowflake, Tableau, Adaptive Insights, Looker, etc. Informatica offers domain-specific analytic solutions for high-tech, energy, life sciences, retail, manufacturing, and finance customers. In addition to all those services, we have also developed more than 15 cloud connectors for IICS. In the slide, the ones mentioned in blue color blocks have been developed by us and also owned by us. And the rest all are developed by us for organizations like Informatica, SAP Calidus, etc. We have developed state-of-art analytic solution Infofiscus, which can be hooked to any on-prem or cloud CRM, ERP, or planning apps. Infofiscus is 100% cloud-based, pre-built analytics software, and it has been developed using open architecture. It can be seen. Infofiscus comes in 3 different flavors: finance, supply chain, and sales and marketing analytics. That's our quick introduction, and now let's move on to today's agenda. Today's topic is data modeling. Before we enter into it, let's see what is data. Data. Nowadays, we want to capture every click, every scroll, every event, every job run. This is a very well-known fact that data is gold. Data is essentially the facts and the statistics that have been collected for analysis. Now let's see what is business intelligence and how this is related to data. Business intelligence is the analysis of past and present data to create actionable insights or reports for decision making. For example, a business can analyze its data to identify which products are being bought by the customers and at what time. With the help of this, the business can develop tactics to boost the potential sales. So with the help of data and business intelligence, we can boost the sales of the business. So I can tell you that data and BI go hand in hand. It is the most critical part of any business. It helps in strong decision making. With the help of data and BI, we can even identify the problems of the business. We can revamp and also refine the business. And also it helps in creating new streams of revenue. All this is possible with data and business intelligence. Business intelligence is like the whole tree, which is the visualization part of it. And data modeling is the root. Strong root is like an anchor to hold the tree in place. Similarly, a good data model will help achieve the best solutions for any business. To achieve a great data model, we need to analyze the data and then structure the data. This structuring of data is called data modeling. Data modeling is the process of creating a simplified diagram of an entire business or a part of a business system. As you can see in the picture, the data model contains data elements, text, lines, and symbols to represent the data and how the data flows. It is a single version of truth. Data models, they provide a blueprint for designing a new database or re-engineering a legacy application. As I've already told you, it can be used to understand and improve the business processes. It is very cost effective and time saving if we build a good data model, as it cuts down the budget of programming, and it also saves a lot of time as we would skip redoing many tasks. As all the data is in one place, there is lesser risk. And we can use these data models to communicate with the client for higher collaboration. Okay, now let's try to understand how to create a data model. So for this, the two things which we would need to know is an entity and a relationship. These are the most crucial elements which are used to create the data model. Entities are the real world things or an aspect of the business we need to store the data about. For example, department, sales, revenue, customers, student. So that's the table or entity. If it is an entity of a student, then we would have attributes in the entity, student ID, student name, etc. about the student. And a relationship tells us how these entities are related to each other. There are three types of relationship as shown in the diagram. The first one is one-to-one, where one row in an entity is associated with one row in the another entity. For example, each student can have only one student ID. Next is one-to-many. One row in first entity is associated to multiple rows in another entity. Example, a teacher can take multiple classes. And here the many cardinality is denoted with a crow's foot symbol. For many to many, multiple rows from one entity are associated with multiple rows in the other entity. A typical example of this relationship is between students and classes. A student can register for many classes and one class can have many students. So this is an example of many to many. Next, let's look at the types of data models. Instead, I can say the three stages of data model. The first stage would be a conceptual data model. The next we would create is a logical data model, followed by the physical data model. The conceptual data model is to establish the entities, their attributes, and their relationship. So for any business, we start off with the conceptual data model. Here we establish all the entities that are required for the business to run, and then we establish their relationships. It is developed to present an overall picture of the system by recognizing the business objects which have been involved. We can understand on a high level how the data flows. The next model would be the logical model, which defines the structure of the data elements and the relationships between them. As you can see, it is the detailed version of the conceptual model. It has been developed to enrich a conceptual model by defining explicitly the columns in each entity. This is the time entity, and the columns in time are date, date description, month, month description, year, week, and week description. So all these are a part of the entity time. And a logical data model will give the keys, the attributes, and also the relationships. A logical data model is still independent of the actual database system in which all these tables would be created. Now let's go to the physical data model. It is the database specific implementation of the data model. So all these tables would be created similarly on the database side. It is the actual design blueprint of the relational database. A physical data model elaborates on the logical data model by assigning each column with the type, length, constraints, etc. Since a physical model represents how data should be structured and related in a specific database, it is important that we consider the conventions and restrictions of the actual database in which all these tables would be created. We have to also make sure that the column types are supported by the database system, and also reserved words are not used in the naming standards, that is naming the entities and the columns. We should make sure that the reserved names are not used. The conceptual and logical models can be very easily understood by business users too, and it would be very helpful to get new streams of revenue. So the conceptual model would have the entities and their relationships. Next would be the logical model, in which we would add the attributes and keys. And in the physical model, it would be database specific, and we would have the column names, table names, and also the constraints for the columns. This is how step by step a business would build the data model. Now let's see what all are very important to build a data model. First, we need to start with a clear plan. We need to have a very good idea of the business process. Then we also need to have a clear dimensional hierarchy, like which table after the other, and as such. We need to have good naming standards. We have to use keys properly and proper planning of the calculated fields as to in which tables they have to sit. And we should not ignore any data sources. Now let's go ahead and see what is a database schema and what are the types. Database schema, data model is the definition, and the database schema is the implementation or shape the data takes in the database side. So the data model is the design for the data irrespective of the storage technology, but the database schema is the design for the data modified to fit into a specific database technology. Star and Snowflake schemas are the most predominantly used to analyze large data sets. These two models are called the dimensional models. On the left side is the star schema and the right is the Snowflake schema. A star schema is a data model that stores information in a single fact table, and it has multiple dimensional tables. They are connected in the shape of a star, and hence is the name. As you can see in the star schema, there is a central fact table, and it is linked via foreign key relationship to the primary key of each dimension. The smaller tables surrounding the central fact table are called the dimensions. This type of data modeling, it allows us to query data faster and with simpler queries than the normalized database design. Now let's see the Snowflake schema. Snowflake schema, it splits the dimensional tables into further dimensional tables, and it resembles like a snowflake. On the right side of the picture, each dimension is split until it is normalized. There is no redundancy of data in the dimensional tables. There is no repetition of values except for the key columns. Querying data involves writing complex logic as the design is normalized. We need to involve many tables in the querying. So star schemas are simpler, run queries faster, and are easy to set up. On the other hand, Snowflake schemas are less prone to data integrity issues. They are easier to maintain and utilize less space. Based on the trade-offs, it depends on the advantage or disadvantage which best suits your business case. Now let us take a look at the different types of dimensions in dimensional modeling. They are slowly changing dimensions, SCD, type 1, 2, and 3. We have rapidly changing dimensions, static dimensions, and confirmed dimensions. Now let us look at slowly changing dimensions. Type 1. Let us consider a table with ID 1001 and vehicular cycle. This is the original table. Whenever a change happens in the table, the value is overwritten in SCD type 1. So whenever the vehicle type changes from cycle to car, then the vehicle value is being replaced by car and the change to table will be ID 1001 and vehicle will be car. So the previous value cycle will be removed from the table. So in SCD type 1, we only have current values. Now next, let us look into SCD type 2. Whenever a change happens, here we add a new row. So when the ID 1001 cycle was the original value, then that value will have an active flag as no because it is not an active row, and the begin date would be from when the value was cycled and the end date would be when the value cycle was closed. So next, 1001 and car will have an active flag Y as it is an active row, and the end date would be an infinite value 31/12/9999. So this is the active record. So whenever a change happens, as you can see, a new row has been added with an active flag indicator and begin and end date, and the old record has been closed. So here we can have history. All the history will be present in SCD type 2. In type 3, whenever a change happens, a new column is added. Here we can see previous vehicle as cycle and the new vehicle as car. So only one historical row is preserved in SCD type 3. The next type of dimensions is rapidly changing dimensions. The dimensions that keep changing rapidly over time are called rapidly changing dimensions. For example, calorie intake of a person. If we create a table for that, it keeps on changing rapidly, right? Next, we have confirmed dimensions. Dimensions that have the same meaning no matter where they are referenced. They can be referenced by many fact tables, not only one. So these are called confirmed dimensions. For example, calendar dimension, location, they do not change, right? Static dimensions are dimensions which do not change over time. These are very easy to implement. For example, date of birth. This is all about dimensional modeling. Now let us look at another type of modeling, which is called the relational model. Unlike the dimensional model, where the motive of the business is measures or aggregations, relational model is designed as the perspective of a business process. So dimensional modeling motive is mainly aggregations and calculations which sit in the fact table, while relational modeling is designed as per the perspective of a process. So it is also called a process flow modeling. So it is used for transactional and operational systems, and it has normalized data structures. The advantages are it has increased flexibility, reduce storage as the data is normalized and there's no redundant data, and data is of high quality, and security is also increased. Next, let's look at another modeling technique called the data vault model. This technique is necessary due to the performance weaknesses of dimensional and relational models as the volume of data increased. Data vault is architected to overcome the shortcomings while retaining the strengths of dimensional and relational models. It is a hybrid approach. It takes in 100% of the data, 100% of the time, like a vault. So all the data is stored in this type of model. There's no distinction between good and bad data. It is designed to be resilient to change in the business environment where the data being stored is coming from by explicitly separating structural information from the descriptive information. So it is resilient to change. Data vault is designed to enable parallel processing as much as possible so that very large implementations can scale out without the need for major redesign. This is a shortcoming of normalized and dimensional models. So now let us look at the architecture of the data vault model. It consists of hub, link, and satellite entities. Hub holds the business keys and no other attributes which provide any description, just the business keys. The link entities provide transactional integration between the hubs, and the satellite entities provide descriptive attributes of the hub primary key. Due to the presence of these link tables, the design is very flexible to any changes in business rules, which is the main weakness of denormalized and relational data models. So there are link tables which are present. Now let us see an example of a data vault model. Consider a business subscription. Imagine we have two entities, subscription and customers, as you can see. The company has many types of subscriptions, varying in costs and levels of services offered, and each subscription has many customers. Each customer signs up with an email ID and has exactly one subscription. So one customer has only one subscription, and one subscription has many customers. So this is the relation between them. So the initial design using dimensional and relational models is being shown on the left side. So subscription to customer, that's it. Because it's a one-to-many relationship. Later on, the business found out that there's a revenue opportunity in allowing a customer to purchase multiple subscriptions. For example, when a customer wants a second subscription for another family member or relative, but under the same account. So now the data model has to change such that subscription and customer becomes a many-to-many relationship. So this model was not present in the initial dimensional or relational models. We need to create a bridge table which will accommodate many-to-many relationships. But this design change will be costly when it comes to relational or dimensional models, as the link table is not present from the beginning. The whole thing has to be redesigned. But for data vault modeling, the link table allows the new subscription model to fit in. So this was the initial design and the future design as well. It will fit in the many-to-many relationship. So for data vault modeling, the link table already exists in the initial stage itself, and there will be no design change. The changes in rules doesn't even require changes in software or design. So this is how a data vault model works. So whatever best suits your business case, we need to choose the relevant model. Thank you so much.
We are now open to questions.
Yeah. I'm having a question that what do you mean by a constraint and types of constraints?
Okay, constraint is something applied on the table, some rules, okay, which are applied on the table attributes. So generally they are like not null, unique constraint, primary key, or check constraint. You know, check constraint is used to verify if the values fall in a particular range. Yeah, those are the types of constraints.
Thank you.
Okay.
So, and what is the difference between data lake and data mart, Satya?
Yeah, a data lake is generally, you know, a bigger picture. It has raw data and also unstructured data. Okay, and it is generally used for, you know, scientific, you know, data scientists to do some research work. And data warehouse is a properly processed and structured data, and it is used by businesses. And designing it is also complex using ETL and all that. While a data mart is a subtype of a data warehouse. It is like a small data warehouse which will meet only a certain department level, you know, standard, and it is subject oriented. Yeah.
Okay.
So that, yeah.
What are the most common errors you found during your data modeling?
Yeah, this is the main part. Okay. The first thing is, if your purpose is missing, if you know your business is, you don't have a proper business process, then it is really difficult to build a good data mart. And then you shouldn't be building overly broad, like 200 tables in your data model, which it becomes really difficult for you to handle. And also, as I mentioned in the slides, the keys, they are really important. What keys you have to use, and what are the aggregates, where you have to place them, and you know, the naming standards. All these are really important. Hope I answered your question.
Hi Satya. So how dimension tables differs from fact tables? Like, what is the major differences?
Right. A fact table generally contains the aggregations, you know, all the calculations, example, net amount, gross amount, what is the quantity, and all those measures. While a dimension table, it will have their descriptions, like what the fact table has, its descriptions. So that is generally how it is stored.
Okay. How about date columns? Like,
Date, you have a date dimension. Date is like, as I showed you, confirmed dimensions, right? So you can use it like that. It can be referenced by many fact tables as well. Yeah. So you can put it as a separate dimension. That will help you a lot.
Yeah, hi Satya.
Yeah.
You showed about SCD1, type 1, type 2, and type 3, right?
Correct. Yeah.
I've seen like SCD2, it is widely used in business.
Correct.
Like, is it so like over SCD1 and SCD2, like SCD type 2 is mostly used?
Yeah. So SCD type 2, because I have showed you, right, it retains the full history of the values. SCD type 3 has only one historical row. So
Yes.
if you need to do the full business analysis and find out what is the problem or boost their sales or anything, then you need to have the history, complete history. So only then we would be able to understand how their growth is over time and all that. So that is why SCD type 2 is mostly preferred in projects. Yeah.
Okay, fine.
Okay, anybody has anything else? Okay, thank you so much for your time. It was really great connecting with you guys. Thank you. Have a great day ahead.
Thank you, Satya.
Thank you. Thank you, Satya.
Thank you.